Welcome. Every massive digital application out there boils down to a single foundational interaction. We'll look at a coffee shop to understand it. A coffee shop is a physical version of the client-server model. It's a computing structure where one program, the client, requests a service from another, the server. Here, you are the client making the request. The barista behind the counter is the server. This transaction happens in 3 distinct steps. First, the request. You ask for a caffeinated beverage. Second, validation. The barista checks to see if you paid and if they have the ingredients to make it. Third, the response. The barista hands you the drink. In the digital world, this exact same 3-step loop applies to everything. Whether fetching an X-ray image, streaming a video, or analyzing weather patterns, you are making a request to a server, which validates it and sends a response. Millions of these cycles execute every second. Grasping this simple loop helps us understand the complex machinery powering global cloud infrastructure. Imagine our coffee shop launches a viral new drink, the rhubarb refresher. Suddenly, 1,000 customers pack into the store at exactly the same time. To handle the morning rush, the shop owner has to hire 10 extra baristas and buy more espresso machines. They are forced to physically build out their capacity to survive the peak traffic. By 2 o'clock in the afternoon, the rush is over. Those 10 extra baristas are now standing around an empty shop doing nothing, and the owner is still paying their hourly wages. Traditional on-premises data centers force a company to buy enough physical hardware to match their highest possible traffic spike, the flat line at the top. But most of the time, actual user demand is much lower. That massive red gap represents wasted money. Owning physical hardware forces a business to bleed cash on idle capacity just to keep the lights on during their busiest moments. To fix this inefficiency, we have to leave the physical limitations of coffee shops and metal boxes behind entirely and move into the digital environment of Amazon Web Services. The AWS solution is virtualization. Virtualization is the process of creating a software-based representation of something rather than a physical one. Instead of installing heavy metal racks, AWS lets you summon digital compute power directly from your browser. When a massive traffic spike hits, you use a process called provisioning. Provisioning is the act of allocating and configuring digital resources for use. You can instantly spin up thousands of virtual servers to absorb the demand. The moment the traffic surge ends, you perform deprovisioning. Deprovisioning is the act of removing or dismantling those digital resources. With a few clicks, you delete the servers you no longer need. By turning the server into a piece of software, AWS eliminates the friction of waiting weeks or months to order, ship, install, and configure physical hardware. This structural shift introduces the core economic pillar of cloud computing, the pay-as-you-go model. This graph shows the concept of elasticity in action. Elasticity is the ability of an IT infrastructure to quickly expand or cut back capacity in response to changing demand. As user demand spikes upward in blue, the green line representing your cost moves in lockstep. The billing mechanism is highly precise. The exact second you deprovision a virtual server, the meter stops. Your costs drop down alongside your demand. Cloud economics completely removes the problem of idle capacity. You only ever pay for the exact compute power your business actually consumes. When you take that single virtual server and multiply it across the massive global scale of the AWS architecture, the possibilities rapidly expand. The ultimate consequence of this system is agility. Agility is the ability to develop, test, and launch applications rapidly. The primary value of the cloud shifts from minimizing hardware costs to maximizing organizational speed. Because you can summon and dismiss resources in seconds, the financial risk of experimenting drops to near zero. If a new software idea fails, you simply turn off the servers and stop paying for them. This agile foundation gives you immediate access to a vast suite of advanced tools. You can plug into massive relational databases or deploy generative AI models without needing to build the underlying infrastructure yourself. Because these resources are available on demand, a 2-person startup working out of a garage now has the exact same computing power at their fingertips as a global Fortune 500 enterprise. AWS detaches computing from the rigid constraints of the physical world, turning massive server racks into a limitless utility that anyone can access on demand to innovate.